Good morning, everyone. How are we doing today? Today, we are going to be moving forward with our next objective, which is the Unit 4, Objective 4. We're dealing with graphing of quadratics. By definition, we've talked about quadratics before, but by definition, a quadratic is when we have a function that's got an x squared term in it. And it generally forms this kind of shape that we see, which is like a curved shape that we see it kind of all over the place. But we've talked about this already. Now let's talk about parts of it. So there's going to be a whole bunch of new definitions that you guys have not heard of before. So try to keep up with them. Go back and look at them and listen. But these are you need to know these words, and they're pretty easy to do. It's just naming parts. Okay. So a couple of the words we're going to be learning about is what's called the vertex. The vertex is the point where our curve will change from either decreasing, which you can see right here, the graph is going down, and then suddenly it starts increasing again on the other side. So right here in the middle, that point is what we call the vertex. So this is where it's decreasing, this is where it's increasing, and we always look at this as we go from left to right. Okay. Versus on on part B there, we can see as we go from left to right, this is increasing as we go from left to right. It changes at this point, and then it starts decreasing. So in this area, it's increasing, and then to the right is decreasing, okay? So that point, as we know it, is called a vertex. Now this vertex we write as a coordinate. So the first answer we're going to be getting for this is the vertex, which is at -1, -4, okay? That point right there is called our vertex. Now I'm going to jump down to the next question here where it says circle one. It's a max or a min. The definition of max or min is basically like, think about when you say the maximum of something. It's the most you can have. It will not get any higher than this. So that's the max. And when we say minimum, it's the lowest amount. You won't do anything less than this. Like if I was to say, what's the minimum amount of work you're going to do to get paid? That's the least amount of work you're going to do. So when we look at this question here, we're looking at the vertex, and we can see that that's the bottom of our shape. And because it's the bottom of our shape, we call this a minimum. It says min, but it's actually minimum. All right. The next thing we're going to talk about is this part of our graph, which is called the axis of symmetry. Now, the axis of symmetry is this imaginary line that we could imagine on our picture, where if I was to draw it, everything to the left, everything to the right, everything up, down, whatever, it would be symmetrical. So like if I drew a line down the middle of my graph right here, this is not going to work. This is not going to be symmetrical because what's above this right here does not look the same as what's below it. That's not symmetrical, okay? We're looking for a line that's going to create perfect symmetry in my picture. That's going to happen right here, and that line is always going to pass directly through my vertex. You can see that on the right side and on the left side, everything is exactly the same. Okay, that's why we call this the axis of symmetry, the line of symmetry. Well, let's think back to what we know. Lines that are drawn perfectly up and down, vertical lines, have an equation. That equation is always going to be x equals something. X equals. And we can actually find what x equals from my vertex, because remember, it has to go through my vertex, right? And so we look at this, and it goes directly through this point. That line right there is called the axis of symmetry, and the equation is x equals -1. That's that x value from that coordinate. Okay. The next definition we're going to look at is what's called the X-Intercepts. These are the points on the x-axis. Okay. And when you look at this picture, you can see that this is my x-axis right here, and we're looking for points where my graph hits that. These 2 points right here, the one on the left and the one on the right, go through my x-axis. They're part of my curve. And these are just a couple more coordinates. So the first one that's on the left side right here, we can see is at -3, 0. And the one that's on the right side we can see is at 1, 0. So there's 2 coordinates. And then the last item that we're looking for is what's called the Y-intercept. This is where my graph hits the y-axis, and that's that line that we just drew right there that goes up and down. We can see that my graph hits right here at this point. That point is your y-intercept, and that coordinate is at 0, -3. So that's it. That's all the parts we're looking at right now. So now it's just a matter of going through each one of these pictures and determining what is each one of these values, and they're pretty quick to do. All right, so let's try. So let's start first with the vertex. Remember, the vertex is the point where my curve changes from increasing to decreasing or decreasing to increasing. And it's right there. That coordinate is at -2, +4. To get there, remember, from the origin, you're going to go left 2 and then up 4. Okay? Since that point is at the top of my curve, we call this a max. Okay? The line that's going to go through the middle of this is right here, and it's going to have the same x value as my vertex, so it's going to be -2. So x equals -2. Oops, wrong marker. X equals -2. The x-intercept is the coordinate that is running through the x-axis. So that's the one on the left is at -4, 0, and the one on the right is at 0, 0. So -4, 0, and then 0, 0. And then the y-intercept is the point where it's hitting the y-axis, and the y-axis is right here. So that coordinate is right there at the origin, which is at 0, 0. All right. So now let's work into the meat and potatoes of this. So it's actually using some formulas when we don't have a picture that's given to us. Can we draw the information from this in order to actually write, to make a picture, excuse me. Well, in order to do this, we have to pull the a, b, and c values from our functions. And we've done this numerous times before. That the a value is the value that's right here in front of my x squared. The b value is the one that's in front of x. And the c value is the one that's off on its own. So this is a -1, a +8, and a +3. Now there is an equation to find the axis of symmetry. It's part of our quadratic formula, which we guys will learn later, but it's -b over 2a. So when we take this, what we're saying is the opposite of b divided by 2 times a. So we get x is equal to the b value in this is equal to 8. So we're going to take the opposite of that, which will be a -8. Over 2 times the a value, which my a value is -1. That means we're going to be at -8 over -2, which equals a +4. So my axis of symmetry for this is x equals +4. Okay? The vertex, what we're going to do is we're going to find the y value when x is equal to 4. Now to do this, we're going to take this x value that we just found, and we're going to substitute it back into these x's that are inside of my function. Now you got to be careful with your signs on this, but let's go ahead and substitute it in there. We're going to have negative squared plus 8 plus 3. And what we're going to do is we're going to take that 4 that we just found for the axis of symmetry, excuse me, and we're going to go ahead and substitute that back in and see what we get. So if we simplify this, we're going to have -4 squared will be 16. 8 times 4 is 32 plus 3. That will give me a -16 plus 32 plus 3, which when we put that all together is going to equal 19. So if we take my x and y, put it together, we'll have a coordinate of 4 and 19. Now let me show you this, what this actually looks like, okay? This is the equation that we just did. We just did y is equal to -x squared plus 8x. This is what the graph looks like. Now, we found the axis of symmetry was equal to 4, x equals 4, and you can see from the picture that we have this imaginary line going directly down the middle at x is equal to 4. When I go ahead and look at that point that's at the top of my graph there where it changes, you can see it's at +4, 19. Okay? All right, let's take a look at letter B. Same thing. We're going to pull our A, B, and C values. Sorry, these are so close to each other. We're going to do a 1, a -4, and a +6. So let's speed this up. X equals -b over 2a. That means that x is equal to +4 over 2 times a, which is 1. So that means that this is going to be x is equal to 2. Okay, so x equals 2. Let's go ahead and throw that in to get our y value. We get y is equal to 2 squared minus 4 times 2 plus 6. It means that y is equal to 4 minus 8 plus 6. So y is going to equal +2. Let's put these together, and my coordinate for the vertex will be at 2, 2. And again, let's look at our picture here. I'm going to turn these two off. We could see that x squared minus 4x plus 6 looks like this. You can see that this is a curve where the bottom is going to be a minimum. The axis symmetry goes right through at 2. And the point where it hits right there is at 2, 2. Okay. All right, let's go back to the next one, and this will be the last one on this video. So we have my A value is -2, B value is +8, C value is 18. Okay. We have x equals -b over 2a. That means x equals -8 over 2 times -2, which means we get -8 over -4, or x is equal to +2. Okay. Now that we know our axis symmetry, let's plug that into our equation to get our vertex. So we get y is equal to -2, 2 squared plus 8 times 2 plus 18. Means that y is equal to -2 times 4 plus 16 plus 18. Y is equal to, let's just simplify that, we get +26. That means our vertex is at 226. And let's confirm this. X symmetry is x equals 2. Vertex is y is equal to, 226. So let's look at this next picture. We can see that our curve is right here, where we've got a maximum, because the picture for this is at, the top of this is, the vertex is at the top, which makes it a maximum. The axis symmetry is x equals 2. If we go ahead and look at the vertex, we can see that it's at 226. That's it for this video. Please continue on and get ready for our second video.